Hello, everyone. Welcome to day one of session two, or a live demo titled Max Rocks. All right, so we have a very special guest with us, Max Pizarro. For those who have gone to our day camps at either Chester or New Windsor, and also in the last couple of years at Camp Bullowa, Bullowa. You will know Max as Aquatics Max or the Duck Guy. I don't know. Max has a lot of different names. He's very enthusiastic. We're very excited to have Max here with us. So what we are going to do, so if you have, Max has a presentation, and then we're going to have you type questions into the chat when it's time for question time. All right. So Max, take it away.
Thank you, John. So for those of you guys who don't know who I am, my name is Max. Like John said, I was the aquatics director at Camp Bullowa for the last couple of years, and I was the ecology director beforehand. Now, outside of scouting, what I do is I am a geologist. I have a bachelor's of arts in geology, and I will be actually attending the University of Mississippi for a PhD in geology as well. So I have some stories and some fun pictures and some cool samples that we're going to look at today. So that way I can show you what I do out in the field and what kind of fun I get into. So let me just share my screen. So you guys should all be able to see my screen now. And I'm just gonna go for it. Okay, just make sure I have everything ready to go. Cool. So what is it that we do as geologists? So first thing, one of the major places that I've been to that I have done field work in is Hawaii. Hawaii is one of these really cool places in the world where it's like so far from everything that it's literally in the middle of an ocean. And what's cool about Hawaii is the way it's built. So Hawaii is in the middle of the Pacific Plate. So what that means is all of the oceans and the continents are situated on these plates that just float on this plastic bunch of rock, which is semi-solid. And it just rides along on top and does next to nothing besides move every once in a while. Now, this specific part of the Pacific Plate has this wonderful geologic phenomenon occurring where a convection current is upwelling in this area and bringing with it some really hot mantle material, which creates a mantle plume. Now, that mantle plume is what drives Hawaiian volcanism. That's just big fancy word for making volcanoes. All right. So the particular, actually, let me grab my pointer. Here we go. Now you guys can see. Now I can point to things. So here I have a mantle plume drawn in my notebook. And this is the basic general shape that happens. As you can see, here's the big island of Hawaii. Here's Maui with its tallest volcano, Haleakala, Oahu here, and then Kauai. There are some other islands scattered in throughout here, but the particular cross-section that I've drawn here, we're not really showing that particular feature. So now to get to the fun stuff, show you exactly what I did. So when we got to Oahu, we actually didn't spend much time there. Oahu was one of those, like, let's get to Hawaii and let's see a couple of things. Let's go to the Hawaiian Cultural Museum, where obviously my trip advisor, my professor, he decided to have a little bit of fun with the Easter Island head and just see a lot of the features. Oahu, we did a lot of touristy things. We didn't really do too much geology. However, we did go up into one of the oldest modern historic features, which is called Diamond Head. Diamond Head erupted roughly, what was it, 10,000 years ago, and was one of the first Hawaiian eruptions in recorded history. And then all over the place, as you can see, things are starting to regrow. It's been 10,000 years, so I'd hope so. And we have all these little guys running around. We have a bunch of birds returning to the area and things like that. And as you can see, from the top of Diamond Head, if this thing decided to blow up again, there's a lot of people nearby. So these are the things that geologists have to ask questions about, because if we allow people to live on top of volcanoes, we have to make sure that we know exactly what's going on underneath. The next island we visited was Kauai. Kauai is one of the oldest in the Hawaiian island chain, and a lot of it dates back to a few million years, so roughly about 5 million. 5.4 is the oldest rock on the island. So the biggest feature on the island is the Waimea Canyon. Waimea Canyon is this really, really big canyon. They call it the Grand Canyon of the West because, for obvious reasons, if I didn't tell you that was a different canyon, a lot of people would think that would be the Grand Canyon. Then, after we went to Waimea Canyon, we decided to head back home, and then we visited Poipu Beach, where we saw the Hawaiian monk seals. These guys are an endangered species. For those of you who are taking fish and wildlife management, that's a good species to know that's native to the United States. That's very endangered. And then we did a lot of hiking. Geology requires a lot of hiking out to places, a lot of studying, a lot of taking pictures, and writing things down. I go everywhere with my notebook. And some of these places, my notebook is literally filled to the brim. There's no extra pages left, and sometimes I have to pull extra loose leaf in there. Now, the next one that I have here is the Nepali coast. Nepali is Hawaiian for, well, Polynesian for cliff. So the giant Nepali here, if anyone has seen Jurassic Park, this particular feature is featured in that film. And going and seeing this firsthand is, you get a sheer sense for the scale of how massive some of these features are. And you just get to know that sometimes what you see in pictures and films doesn't really do things justice. And like I said, hiking, this is actually a spot underneath a grove of koa trees, some very, very endangered species of tree that we can see in some of these places. And like I said, just hiking everywhere. Now, Maui was very interesting because Maui literally translates to the Valley Island. So what that means is you have one volcano to the east and one volcano to the west. And the valley in the center is where everybody lives. Now, at the top of the tallest volcano, Haleakala, this is where some astronauts actually train for when they go to the moon or when they go into space, because it is so devoid of any life versus what we see around the rest of Hawaii that it's very, very strange to see. And it was one of the coolest places I've ever been. Now, as we descend down the mountain, we do get these beautiful waterfalls and these massive pools. These pools are caused by rocks that literally get trapped into a hole, and those rocks just spin as the water moves around the rock spins, and it carves a deeper hole. We saw sea turtles. I actually I have another picture that I couldn't find that I really wanted to use, but I was snorkeling off the coast of Maui, and a sea turtle decided that he was going to swim up next to me. Now, sea turtles are really endangered, so as soon as you see one, you have to stop moving. And I couldn't move, but he just kept coming closer to me because animals are curious sometimes. Now, this particular sunset here that I have, you see the outline of another island out here. This is Ko'olave. That's a mouthful, I know. Ko'olave is a smaller island off the coast of Maui, which is part of the major 8 islands in Hawaii. I'll go back to the map in a moment so I can show you exactly what I mean. But this island is restricted. You can't access it unless you are a native to the islands. And then I just threw in a gorgeous Maui sunset for the effect of seeing what Maui has to offer. Now, when we get to the Big Island is where we start to see a lot of things that we think of when we think of Hawaii, like volcanoes, different colored sand, all of the sea turtles. Yes, here's another sea turtle. This is the guy, I call him the grumpy old man because that's what he reminds me of. So let's take this picture first, since it's the first one on the page. So this is a typical geology photo. Anytime a geologist takes a picture or draws a picture of any geological feature, there is going to be something in there for scale. Now, in this case, I have my rock hammer, which is 1 foot from the bottom to the top. And that just gives you a sheer scale for the size of this peridotite. Now, that's just big fancy rock talk for what the rock is called. And I'll get into that when I start showing you samples on how we name the rocks. So just bear with me for a moment. And then we have the green sand beach, one of my favorite places. I do have sand that I will show you later from the green sand beach. And here's a picture of me holding the sand. And then the biggest volcano on the planet, which is also the biggest mountain on the planet, rises 24,580 feet from the bottom of the sea. And only we get to see 14,000 feet of it. This is Mauna Kea, or the White Mountain. And this is the biggest mountain on the planet. Now, we usually think of Mount Everest as being the largest mountain on the planet. Mount Everest is actually the second largest mountain on the planet, next to Mauna Kea. And then I have, when we first got to Kilauea, which is the fiery mountain, and you can see the steam vents making clouds coming from the caldera pit. All right, so a couple of you may know if you had me for geology last year, but those of you that don't know, there was an eruption that happened in 2018 at Kilauea. So Kilauea is outlined here in red on the map of the Big Island. And what happened was lava began to move from the top of the volcano down through a rift zone. What that means is big giant cracks opened up to the east of the volcanic peak. So right here where my pointer is where those fissures opened. And here's the top of the volcano. Now, when all of the magma left the chamber underneath this very big word, I'm going to say it, It's Hale Ma'u, which was the lava lake that was in this area of the caldera. Once that began to drop, the entire caldera floor became unstable. What happened was it just dropped. Okay? So this diagram here shows you with the Empire State Building actual size for scale. This is elevation in feet above sea level. And this is lateral distance in meters. This is a very drastic drop in distance. This went from nearly 1,200 meters above sea level to almost 600. That is literally half of its distance, and it just dropped that complete distance. When we were at the top of the mountain, we did experience a couple of earthquakes as the ground was still settling. And it was very interesting to see as a geologist, because it just goes to show you exactly what we don't usually get to see. Now, this is the caldera as I showed you here. So this deep portion is down in here in where this yellow part is. Now that yellow is all sulfur. And I have some sulfur that I will show you later. And as you can see, these giant cracks are hundreds of feet. This particular cliff right here is 200 feet tall. And this goes down another 300 meters. That's the length of a football field. And one of my favorite things about this picture, if you see this picture down here in the corner, go away. This picture over here was taken right here. As you can see, if we followed the road any further, eventually we would run out of road because the road actually fell into the volcano. So the road, which ends right here, fell into the volcano because it originally went around like this and it picks back up over here, if you can follow the line. This just shows you how powerful this eruption was. It just decimated the crater rim. And now we have a new crater that we can study and take a look at. Now, I did tell you that we had a bunch of new cracks open up. So this particular feature right here and here is called Fissure 8. Fissure 8 opened inside of a housing development called Leilani Estates, and it was the predominant feature that produced lava during the 2018 eruption. Now, by the time we got there to study everything, this particular feature had stopped producing lava, and now Kilauea sits dormant for the first time in over 50 years. But it still is the most active volcano on the planet at the moment, because it's still producing steam and still producing earthquakes and things like that. So we know things are still moving, but we don't know is when Kilauea is going to reactivate and actively produce lava. Now, here are some pictures of us doing sampling. I am right here, and obviously I'm sampling this particular lava flow up here. Now, in Hawaii, we give lava two different names based on what their texture is. We have this first one here, which is kind of blobby and doesn't really look like too much. And then we have the one that's very sharp. Now, I'll give you I'll give you a hint on what the one that's sharp is. When the Polynesians were walking on it, all they said was ah ah, like because it hurt. So we call that ah ah. And then the ropey material, which looks like blobs, we call that pahoihoi because it's comfortable to walk on. I didn't come up with these names. The ancient Polynesians did. So we're going to go with what they said. Now, to give you the sheer size of what happened, so here is a map of the eastern side of the Kilauea volcano. And Leilani Estates is over here. And here, each dashed line is a fissure. And then running along here, this is what the old coastline was. Now, this right here was Kapoho Bay, this particular feature. Kapoho Bay was completely filled in, and the coastline pushed all the way back out. Now, down here at the Isaac Hale boat ramp, this particular boat ramp doesn't exist anymore. It's now the Isaac Hale Beach, because now there is a brand new black sand beach there. Now, that's really all I have to show you about what happened. Now I'm going to show you some of the samples that we took and tell you a little bit about each of them and how we name some of these rocks. Okay, so I'm gonna stop screen sharing so that I can show you these things. And I will bring this here. Now, the first one is probably the biggest one. This particular sample is one of the pahoihoi pieces that I sampled from the particular place that we went sampling in that picture. That particular piece and this little one right here are from the same flow. And those rocks are 2 years old. 2 years. That's younger than everyone here. Like, wow, how can rock be 2 years old? And we're like, and then we have some rock, which I have another piece, is 2.3 billion years old. Some of these things, it's just really fascinating to take a look at. Now, I have a couple of things that I am going to show you that aren't from Hawaii, but they are from New York. And these are things that I've actually sampled and studied for different classes, different things that I've done. So, for example, I have what we as geologists call skarn. So, what this basically means is it's a rock that has two different compositions to it. It has a piece that forms from lava and a piece that forms from sediment. Sediment is basically dirt. Okay? So that's this particular one. Okay? Now, what we do as geologists in order to study these things, we break them down into their basic components. So all of these green little bits that you see, the darker bits, we would poke out with a special tool. Not really special, we use dental picks. And then what we do is we crush the material into a fine powder. Then once we have the fine powder, what we can do is we put it onto a special slide and put it into a machine, and that machine will tell us exactly what it is. And then once we're done, we can write that down and we can figure out exactly what it is based on a known composition of what the minerals are. Now, for a rock like this, like my lava, it's not necessarily that easy because a lot of lavas are just filled with volcanic glass, which I'm trying not to cut myself on right now. The volcanic glass is 0 crystals, okay? That's how we know that it's glass. And the difference between, say, quartz and a volcanic glass is the fact that quartz is actually a crystal. Now, a lot of you know what quartz is. A lot of you have probably seen a Herkimer diamond. That's what quartz is. Quartz is one of the most abundant minerals on the Earth's crust, and they typically you find them almost everywhere that you have granitic bodies. So granite is one of those things that we find in New York, and a lot of that material, when you have mixing of these sedimentary bodies and the granite bodies, is how we get something like this. Okay. Now I have another fun piece right here. If my camera will autofocus. Found at the same place that I found this is what we call a fluorapatite. It is a bright blue crystal, and I wish I could show these all to you in person because they're so much cooler in person. Now, earlier I mentioned sulfur. Sulfur is a yellow mineral, and it smells like rotten eggs. So it's not very fragrant. Now, there are rocks that are lighter than water. And I do happen to have a piece of pumice, which is lighter than water. I don't have water nearby that I can show you this because I'm at my computer. But I will probably give this to Dan and Kim, and I will let them show you guys. Just drop this in water and it will float. I have some volcanic ash. So what's different between regular ash and volcanic ash is that volcanic ash is microscopic glass shards. They are, excuse me, they are microscopic glass shards. So you have to look through a microscope to be able to see them, but they are very sharp, where ash from like a campfire is not going to be like that because it's just carbon. Speaking of carbon, carbon is what diamonds are made of. And I have a diamond lying around somewhere. Oh, here it is. There's my diamond. Going back to Hawaii, like I promised, my jar of sand. I have the green sand. It is very green. And I will, just to show you how green it is. Let's put that back. There we go. Now, the reason it is green is because of the mineral that it is. Now, there are only a few minerals that are very green like that, and the particular one that is called olivine. Now, if you remember the one picture that I showed you with my rock hammer in it, that basically had a piece that looked like this, it's the same thing. Olivine. Now, uh, Papakolea Beach, which is the green sand beach that I visited, is one of 8 in the entire world. And you can't really get to it without taking a 2-mile hike. Like I said, doing geology is a lot of hiking. So if you like hiking and enjoy being outside, geology is going to be really fun for you. Now, like I said before, you can't do science without writing things down. So everywhere I go, I take one of these guys with me. These are a field journal. Now, my field journal is basically where I write down all of my findings and where I do everything that I need to do in order to do my science. For example, the map that I showed you, I drew in here. Any of the maps that I showed you, any of the diagrams that I showed you, are all ones that I did for being in the field and being in my journal. Now, there's a couple of places that I did visit with geology that I didn't share with you. I visited Barbados and Montserrat, where I visited limestone reefs and another volcano. And some of those places you find things like this. Now, this, a lot of you probably know what this is when I say its name. This is obsidian. Obsidian is pure volcanic glass. Now, the way it forms is really the only thing Minecraft got right. You basically flash quench a lava so that you don't have any crystal growth. And then what you get is this glass. And that's what obsidian is. Let's see, what other fun things do I have to show you guys? Let's see. Another fun mineral that I have is topaz. For those of you who were born in November, this is your birthstone. Topaz is a gemstone that is actually a benchmark mineral for one of the tools that we use is the Mohs hardness scale. It is a scale from 1 to 10 where we rate how minerals are, okay? Diamond being the hardest and talc being the softest. Topaz is one of our benchmarks. Topaz is 8. Let's see. What else do I have that's fun? And I just remembered that I pulled this out. Those of you guys who were at camp last year, you guys got to see this in person. However, one of my favorite specimens that I have is a lunar meteorite. So this meteorite is actually part of the moon. So to give you an example, here is the sheet that tells you exactly what it is. And then here is the actual sample. Now, this particular meteorite is from Northwest Africa. There we go. I have to make sure that I can keep it right in front of there. Northwest Africa. Its exact location is unknown, but it's a lunar meteorite. So what happened was a meteor hit the moon, blasting moon dust into the atmosphere of the moon, and then it falling down to the earth as a meteor. And then humans, we find those things and we can study what the moon is like by looking at these rocks. Let's see. And I think that's about all I have for you guys. So I hope you enjoyed getting to be geologist for a little bit. And I really enjoyed getting to tell you about the work I've done. I'm going to turn it back over to John, and we can open it up for questioning.
Yeah, thank you, Max. Thank you so much. Everyone give Max a big round of applause. Thank you, Max. Max rocks. Yes, we do have a couple questions. Now, please start sending your questions to me in your chat. The very first question I have here, well, the first one I'm going to read at least, are any rocks lighter than air?
So we do have a couple that are close to the density of air. However, none of them are lighter than air. There is one called, the name is escaping me, but basically the way it forms is you build up a lot of pressure, a lot of pressure. And has anyone ever shaken a soda bottle and gotten the carbonation? That's exactly what happens when this rock forms. It's escaping me. Reticulite is the name of that. And it basically, it looks like tiny bubbles, but it's tiny little, like a spider web of glass is what it is. And it is very, very, very light and very fragile.
Awesome. I have a question here from James. What is the difference between extinct and dormant volcanoes?
Okay, James, that is a very good question. So dormant means that it has the potential to reactivate. Extinct means that it will never reactivate again.
Awesome. Another question here. What was your favorite thing you did on Oahu?
My favorite thing that I did on Oahu would have to be when we visited Pearl Harbor. It was probably the coolest thing we did on Oahu. Like I said, Oahu, we were only there for 2 days, and we did a lot of the touristy things, and we didn't really do any real geology on the island.
Great. What was your first ever geology trip? From Michael Lombardi.
My first ever geology trip. Well, that would have to be the first weekend of my freshman year of college. We went and we visited secret caverns up in Cobleskill. And I have a really fun picture of one of my professors looking like she's jumping into the underground waterfall.
Where was this? Was this in Howe Caverns, you said?
Secret caverns.
Yeah, okay.
Basically across the street.
Oh, okay, got it, right.
Yeah.
Can rocks be formed by the sun?
That is a great question, and the answer is sort of. Now, what happens is you have deposition of sediments that occur, and the sun can dry them out. And if there's a cement in those sediments, then those particular sediments can become rock.
Okay. What is the rarest rock or mineral in the world?
There is a bunch, but I can tell you diamond is not one of them. Actually, I do have one that is one of the rarest. Let me just grab it. One of my prized samples in my collection. This little blue guy is called tanzanite, and he is one of the rarest minerals on the planet.
Where can you find that one?
It's only found in Tanzania, and it's only found in one specific part of Tanzania, and that would be the south.
What is the lunar meteorite as a type of rock, and do you know where on the moon it is from?
I do not know exactly where on the moon it's from. However, it is classified as, and this is a mouthful, so bear with me. I'm going to try and say it as slow as I can. It is a feldspathic regolith breccia. So what that means is...
Bless you.
Thank you. So I'll say it again. It's feldspathic, which means it originally was part of a magmatic system, regolith, which it's not, it's lithic, so it's part of the crust, and then breccia, meaning that it was broken up at one point and then resolidified.
All right. I think are all volcanoes dangerous?
That depends on the type of volcano, believe it or not. But yes, the short answer is yes. All volcanoes are technically dangerous. However, some are less dangerous than others. Now, there are 4 basic types of volcanoes. There are really 2 that we concentrate on. The first that we concentrate on being a shield volcano, and that's where Hawaii comes into play. All the Hawaiian volcanoes are shield volcanoes. So they look like these big shields, and they just look like giant hills. And then there are the composite volcanoes, which are what you think of, the big triangle-looking guys, like Mount Rainier. Mount Rainier or Mount Fuji is the one that comes to mind when everybody thinks of a composite volcano.
What is the oldest rock?
The oldest rock. Well, the oldest rock that I have seen and actually held personally is from my senior thesis, the Dana Hill Metagabbro from St. Lawrence County, New York. That is roughly 2 billion years old. However, the oldest rocks on the planet date back to 4.5 billion years, and you can find those in the Skaergård in Greenland.
Wow. That's really old.
Very. Those
Okay.
are back from when the Earth formed.
All right. So we got to wrap up just a couple more questions. Have you ever personally, Max, discovered a new rock? Is there a Pizarro rock somewhere?
I have not. I'm working on it, though.
Okay.
I am working on it.
All right. You can dig in my backyard if you want. That'll
Thank
help
you, John.
How deep under the surface have you been?
How deep under the surface have I been? I think the deepest that I've been is 400 feet. And that was in a cave.
Okay.
Yeah.
Why are Herkimer diamonds called Herkimer diamonds?
So, people, when they were first exploring America, they were looking for exploitable resources, and diamonds being one of them. And this guy, Herkimer, happened upon these things that appeared to look like diamonds. And he's like, these are diamonds. They're real diamonds. Turns out they're not diamonds. They're quartz. So we actually just call them Herkimer diamonds because it's tradition. So that's the name we give to doubly terminated quartz. That just means that there's 2 points on the quartz crystal versus when there's just 1 point on the crystal, like this one.
Okay. So Max, final question. So you're a lifelong scouter, you're an Eagle Scout, you worked on many camp staffs, and you are now a geologist going to be working on his PhD. How has scouting helped you, and did it help you realize your dream of playing with rocks and being a geologist?
Oh, of course. Scouting has been something that's opened many doors for me, especially when it comes to getting into grad school and getting into school and knowing things that other people just really didn't know how to do. Like some people have never been camping before, and they pick up the geology major and they are like, oh, I've actually never been camping before. It's like, okay, I got this. Let me help you out. And things like that. Knowing how to use certain tools, and things like that are always things that I can look back and it's like, oh, scouting helped me with that. So
That's great.
that's how scouting has helped me with this.
Well, Max, thank you so much for coming. That's all the time we have today. Everyone, please give a big round of applause for Max Pizarro. Yay! Thank you, thank you, thank you. And Max, we will see you next time. Everyone, we'll see you later at 3 p.m. Cub Scouts, I hope you're having fun with your projects. And